Everywhere we look, problems surround us. Some are simple, like staring at a to do list that feels impossible to finish or even to start. Others are more complex, like when a team loses trust after a project failure and every decision turns into a battle. And then there are wicked problems, those tangled systemic challenges with no clear answer. Think about AI. As we rely on it more, are we strengthening our abilities or slowly eroding them? For industrial and systems engineers, solving problems is at the very heart of the profession. But here's the catch: the tools that work beautifully on one kind of problem often fail miserably on another. So the real question is, how do we match the right approach to the right kind of problem? On this episode of Problem Solved, Tom Wujec walks us through a method called wicked problem solving, using visualization tools that equips you to tackle everything from the simplest task to the most wicked problem.
This episode is brought to you by IISE's Performance Excellence Webinars, helping you grow your career with skills in leadership, supply chain, analytics, and more. You can find the full webinar library anytime at iise.org/performance-excellence.
Hi, everyone, and welcome to Problem Solved, the IISE Podcast. Today, we're talking to Tom Wujec, a designer, technologist, TED speaker, and global authority on creative collaboration. Tom has helped Fortune 500 companies tackle some of their toughest challenges, guiding leaders in industries from manufacturing to healthcare to retail. He's the creator of Wicked Problem Solving, founder of the Wujec Group, and best-selling author whose books and workshops have inspired teams worldwide. Tom, you are a professional problem solver, so it's great to have you on Problem Solved. Thank you for being here.
It's my pleasure. Thank you so much for inviting me.
Well, many of our listeners may know you from the TED Talk stage, where you've shown how playful tools like marshmallows, spaghetti, and doodles on sticky notes can help solve really serious problems. So I'm just curious, what first sparked your interest in using these tactile and visual tools for problem solving?
I began my career studying astrophysics and physiological psychology, and I found that in order for me to understand how the world worked, I needed to create a picture or an illustration or a sketch or a doodle. And I found that a really powerful tool to make sense of the world that we live in. When I shifted from school to work, I became creative director, eventually, of Canada's largest museum, the Royal Ontario Museum. And we would have teams that would work together to create exhibits, to tell the stories of science, nature, and discovery. And as so often happens, everyone had a different concept, a different mental model of what was important. The curator said this, the educator said that. And so the usual way of talking didn't quite work because people would go around in circles. And what we learned in the design phase with the design group is that when we made ideas visible, when we literally posted sticky notes on the wall illustrating what people said, the meetings changed. People shifted from talking at each other to building a shared framework. And so we moved from a confrontational way of working to one in which we collectively built a common shared picture. That actually ended up being a powerful tool that I ended up using in building software, helping organizations figure out how to build faster, better cars, and so on.
Yeah. And just a quick note for our listeners, we want to invite you to check out the video of this episode on YouTube to really see Tom's visualization method in action. Tom, can you tell us about the technology that you're using today? I think you designed it.
I did, actually. So for those of you who are watching this, I am in front of a large tablet. It's called a Cintiq tablet, and I will be drawing and dawdling, and making simple sketches to help illustrate the points. Normally, I have very rich, sophisticated, interactive 3D graphics. But for today's conversation, I thought it would be much more interesting to have loose, sketchily drawings, because that's kind of what we normally do when we solve problems visually. Getting up to a whiteboard, you know what this is like, and starting to create lines, boxes, circles, 2x2 diagrams to make our ideas visible. So those of you who are watching will see an application called Sketchbook Pro. It was interesting because we took a $40,000 graphic application that required the horsepower of a Silicon Graphics workstation. Some of you know what that is. And then we parboiled it down into a $200 application. And eventually we made it available for free. So at one point, 40 million people were using Sketchbook Pro.
Wow, that's amazing. So, industrial and systems engineers are trained to solve problems, but when uncertainty or scale or people get added into the mix, those tried and true methods don't always hold up. And you've talked about how problems fall along a spectrum and how our brains often struggle when we treat all problems the same way. Can you talk a little bit about why old problem solving methods fail us sometimes, especially when things get more complex?
Sure. So problems fall along a certain spectrum, and I think we all intuitively know this. There are simple problems that have relatively few elements to them, few nodes, few connections. And then there are complicated problems like figuring out tax code, where we know all of the elements, but there's lots of them that kind of tax our brain. And then we have the complex problems. So these are problems where we don't know all of the elements, and many of them are fluid or ambiguous, sometimes emotionally charged. They're harder to solve. And then there are the wicked problems, which are often vast. The grand challenges are wicked. Climate change, the impact of AI have elements that we don't know about, and even different people frame the problems in differing ways. So in order for us to be able to tackle and tame these problems, we need to select the kinds of thinking that suit the problems.
Okay. And so when we're in a group, we have some limitations on us. You can't predict how other people are going to react. Everybody's brains work a little bit different. Can you talk us through how to navigate that?
Sure. There's lots of problems with problem solving, but they kind of can be boiled down into three big buckets. The first is our limited brain power.
Yeah.
We evolved to be able to attend to 2, 3, 7. I don't know if I can attend to 7 things at one time. And so our attention is a limiting factor. We only can keep so much information in our internal working memory. It's limited. It has a cap. Secondly, different people have different working memories. They have different dynamics of how things fit together. A lawyer sees a situation in one way. A programmer will see a situation in another. A systems engineer will see it in another. So we all have hammers to see the nails, to address the nails that we see. And then thirdly, we don't typically use a shared process of creative collaboration. So the combination of these three factors, limited brain power, the differing dynamics of people, and an ad hoc method of problem solving prevents us from focusing and getting the genius out of the team.
Okay. So how do we tackle this? And you've talked about using kind of sports as an analogy. Can you talk about that?
Sure. So we use the concept called plays. So play is a time-bound, structured activity that guides people through a particular activity. When you think of a sporting event or a sporting team, the team that has the best plays and runs them well is typically the one that creates the goals. So what plays do and we'll explain what a wicked problem solving or problem solving play looks like in just a second, is they give us a sense of psychological safety because there's a process and a method for us to move forward. Secondly, they help us see ideas so that we're not just talking, but there's a visual component that allows us to make information visible, persistent, and movable. That's really critical. And thirdly, it transfers the way in which we interact. So rather than just argue, debate, which is an important factor, we are building a little systems model of the problem at hand, different options, and how we solve them. So the interesting thing is that system engineers are experts at this. And so what I'm here to share are how to apply these innate skills that you've cultivated into other types of problems that you may not address or that you'd like to address better. And so before we get to that, what I'd love to do is to talk about the elements of a play. In a sporting event, there are physical actions, mental actions, psychomotor skills. In wicked problem solving, you can boil it down to 3 things. First is to use questions. Lead with questions and use questions to focus and frame the topic. And by selectively and strategically using questions and asking them better, we become instantly better problem solvers. Second is to make ideas visible. The simple act of creating a visual representation of the thing that you're working on, which can be a doodle, a sticky note, a word, a chart, a systems model, whatever is appropriate, helps us externalize our thought, take it out of our head and into a shared surface so that we can expand and multiply our working memory. And then the third thing is to think about what are the tasks that we can perform to solve the question, to answer the question, typically using some visuals. So posting, drawing, sorting, rearranging, voting, all of these very simple actions lower the transaction cost of going through the problem. Okay, so 3 principles, and it's simple. Questions, make them visible, and then have some clear tasks. So let's show some simple plays and how you can work through them.
Okay. So how would we run a play to tackle the problem, kind of a simple problem of somebody feeling overwhelmed? They have too much to do. How would a play look like?
Sure. So it's really simple. So the first thing that you do with a simple problem, you've got too much to do.
I love your drawings.
is to make some space. So create a physical space or digital, but physical space has an added benefit of engaging your physical body, and it's something that we remember as kids and we've done as kids, but we forget as professional adults. But the simple act of writing physically and using physical sticky notes changes how we interact with the information. So create a stage, and so that can be a whiteboard, a book, some sticky notes, a laptop with some sticky note software like Miro or Mural or one of the other great ones as well. And you frame the question, which is, how should I organize my day or week? So you begin with the question, and then you have a space within which to run your play. The first step of the play typically is to populate it. You write what is on your mind. And so typically using a number of notes, you do what's called a mind dump, and you exhaust. You get all of the ideas out of your head onto a surface. That can take a minute, 5 minutes, often 10 minutes, sometimes even more. And that act, once you get to the final thing, is remarkably liberating because you've exhausted, you've performed a transaction in which you have systematically created a data object for each of the elements that are on your mind. Then what? You make sense of them. You arrange them into various structures. So by making it visible and adding a visual structure, you add another element. So what kind of structure? You can organize it from non-urgent to, or something you can do now to something that you do later. So simple. Or you can arrange it onto a 2x2 diagram. We're all familiar with the diagram of urgent and not urgent, important and not important. And those diagrams, those sticky notes can be arranged into the diagram. And there are others that you can also choose depending on what's the underlying thing that's bothering you. So maybe it's something that you're ignoring. So what are the things that you're ignoring and what are you addressing? So the act of making visible the mental model that you have becomes a very powerful tool to diffuse the power of it, but also to help you get to clarity and figure out what's important. Typically, people will then just do a voting activity and then turn it into the actual execution plan. So if there's one thing that I would love for you and your listeners to remember is the term space. To solve problems visually, you go through a process of making space. So this is both literal and figurative. It's literal in the sense that you create physical space, a place to think, to communicate and to collaborate, but also a psychological space. You pause and go through a series of simple, easy to do steps which support and reinforce your thinking. Each of the letters represent a word. So S stands for stage. It's all about creating a physical or digital place where you can make your ideas visible. The next word is populate. And that means you, within this stage that you've created, you place information, whatever it may happen to be, from to-do items to customer needs to issues, into that space. Super simple. Next is arrange the items within the space that correspond to a model, and we're going to talk about these in a second, that supports the problem to be solved. If it's a timeline you need to arrange, you arrange it in a timeline. If it's dilemmas that you need to arrange and organize, it's within a 2x2 matrix. If it's some other model, like what is hidden, what is surface, it's another drawing. If it's a root cause diagram, it's another. So the visual structure supports and reinforces the mental model that you use to solve the problem. Next, you choose. So of the model that you have chosen, you can select the elements that are relevant, and then finally exit, which is converting the complexity into a task list. Complexity is the enemy of execution, which is a phrase I once heard, and I love it. So we, through this process of making space, staging, populating, arranging, choosing, and exiting, we have a kind of a universal model that can be applied to simple, and as we'll see, to complex, complicated, and even wicked problems.
And it does seem quite intuitive. You know, you take a breath, you do a brain dump, you sort of prioritize, and you make a plan. And once you see it all laid out like that, it doesn't feel quite so overwhelming.
So what I also want to say about space is that making the habit of taking 10 minutes a week or a day can be transformational. I've worked with a very wide range of organizations, and one of the practices that I'm seeing many companies that make footwear and large retailers and car companies, AI companies, is that at the beginning of the week, the teams need to get together to talk about what's important. And typically there's a structured process of doing it, but often one of the most simple and powerful ways is to just create a group space, large whiteboard, where people simply share what's important, a weekly stand-up. Everyone writes silently on sticky notes. They place them up on the wall in no particular order. Everyone can see what's on everyone else's mind. It's happening in parallel. And then they go through a process of what's called a silent sort, where anyone can move any note anywhere to find common clusters. And what's powerful about this is that you may begin with 15 different notes of differing points of view, and then they can get clustered into a few categories, which the group then decides upon. So there can be hidden issues that are surfaced or issues that then get targeted. The difference here is that you've moved from working linearly, talking, where one person might command, and then you'll have 10 minutes of conversation, to one which you do a 3-minute exercise where you get to see everyone's ideas all at once, not just the one person who's talking, and then a collaborative activity where you bring it all together into a common framework. So that simple shift of having a visual workspace, the practice of populating ideas, putting them up onto the wall, is something that can be done for very simple activities. And then we train people to do this for much more complex issues, such as their thought leadership strategies, or building surgical playbooks in developing countries. So again, that simple transaction of making space can be applied to increasingly deep and rich levels of conversation. So it's a great practice that you may want to explore and try. If there's a second thing to do, get a really good whiteboard or a movable whiteboard.
Yeah, I would also imagine that in that kind of exercise has to be a pretty kind of a safe culture for everyone to feel safe and putting what they're thinking, just putting it out there for everyone to see without judgment.
It's true, and so people who lead this practice are ones that make emotional space available. So
yeah.
There's no judgment. There are differing phases of creative work. Pixar uses a term called creative collaboration, we'll talk a little about that in a little bit more detail, but there are differing phases of creative work. One of which is called creative abrasion. Now there's creative agility. Now there's creative alignment. Creative abrasion is about making space available to build a marketplace of diverse ideas. When the manager, who needs the skills of welcoming, of inviting diversity of ideas and of concepts, and providing them with merit, so you're not immediately dismissing the ideas, but you're incorporating them as part of the whole, is a really valuable and increasingly vital management skill. Being able to manage this marketplace of ideas is a critical tool, and only one of the entire creative collaboration process.
We'll be back with more right after a word from our sponsor.
The season premiere of Problem Solved is sponsored by IISE's Performance Excellence Webinars, your chance to boost your career and expand your ISE toolkit. From leadership development to supply chain resilience to operational analytics and more. These sessions help you sharpen your skills and improve your organization. Join thought leaders and practitioners from around the world. Learn more at iise.org/performance-excellence.
Welcome back to Problem Solved with Tom Wujec.
Very often we're asked to solve a technical pipeline or improve how teams will work together. And what we found over the last decade or so is increasingly organizations struggle with the concept of trust. Not even the concept of trust, but the dynamic of trust. How when a project is broken, or if teams have differing values, or they've had some bad experiences, trust is broken, and as a result, the team dynamics doesn't really work. So engineering methods typically don't work so well to deal with these more nuanced issues. So we did a project for a large games company. They're one of the largest games company in the world, and they have a dozen and a half studios globally. And so they were looking to build or integrate a common gaming engine between the studios. And it wasn't working. And this is a problem that they were struggling with for about 10 years or so. So they invited us in to help figure out what are the technical dynamics. So we went through several meetings to help frame and to explore what was the real problem underneath. Fast forward, after 8 weeks, finally one of the group members said, I think it's a problem of trust, a lack of trust. So I'd like your listeners to think about what plays would you run? How would you go through a process of staging, populating, arranging, choosing, and executing trust? And then what I'll do is I'll share some examples of how we did do this. So we framed the question of how do we rebuild trust? Even the act of saying that was a powerful tonic, because folks would go, yeah, that's actually the problem. And then no one kind of really made eye contact for a while. So how do you tackle it? So here we went through several gentle phases to make the transaction cost low, easy, and even fun to be able to dig into the nature of this complex problem. So our first pass of going through space was to frame the question and then ask people to define what is trust. And so people would begin talking in small groups and go, no. Let's use sticky notes and let's populate them on the wall. So people would, each person would have 6 or 8 different qualities of trust: empathy, understanding, vision, trustworthiness. Of course, what does that mean when you're defining trust? And so we would have many arrangements of them. And then we asked them to cluster those into a single framework. So what are the common clusters of trust? So what do we align on? And what we then ended up having is a visual structure, which is actually a equation, and since many of them were engineers, this was just really up their alley to clarify what trust meant. And so learned this working with the chief technical officer, CTO of Lucasfilm about 25 years ago, when he was sharing his insights on how to make his teams more effective. And he said that his CTO 20 years ago did this. He made a napkin. I still have the napkin over there in the back studio there. And he wrote the letters T, which stood for trust, equals C times C times C all over R. And so you might ask the question, what do the letters stand for? And so in his framework, the first C was capability, your ability to get things done. Are you able to do what you say you're going to do? Next was character. Are you true to your word? Will you follow up? And will you do what you say you're going to do? And the third was caring. Do you give a flying... I use some colorful language there. Are you empathetic? Are you willing to put someone else's needs at your level or even higher? And so these qualities, the higher they are, the higher the trust is on the other side of the equation. And so what this did is externalized the act of talking about a gnarly subject where we can get self-conscious into something that becomes externalized and easier to talk about and easier to measure. And so when a project derailed, they can talk about, was this a problem of skills? Was this a problem of not following up? Was this a problem that you had other priorities? And then by addressing those, you can change the behavior, and it changed how people worked. R is the one that I didn't get. So what does R stand for?
Risk.
R stands for risk. You are correct. So the higher the risk or the higher the impact of this issue or project, the higher the C's need to be in order to create a trusting equation. So this is one, and it works really well, but it's even better to have a group actually go and build their own equations for trust. So I have dozens of these, and they're all variations, and some of them have sigma and equations and all kind of, because we do them with engineers, but they are accurate models of what people feel is important, the important elements that underline and underpin trust.
Yeah, that makes so much sense.
It does. And so again, we take these plays. So each of these are plays that breaks down a complex problem into smaller constituent parts that are easier to follow and easier to get right. So, and each of them have this visual component. So again, how do we build trust? We have a blank spot. Then we have a space where everyone has drawn their sticky notes. Then we have this equation. And so people generate their own equations, or they can use this one here. And then they compare their equations and go, how does my equation fit with your equation? And so typically there is a delta in one of the key groups there when we've ended up visualizing trust as a bullseye, what was most important. And T which was transparency for one group, was way off to the side, and another, it was right in the middle. And that was the block that prevented them from collaborating, because one group felt that they were trying to communicate and others were ignoring the acts of transparency, and then others were like, you're not giving it to me. And so it created an emotional dynamic. So again, here we're talking about classes of problems that are that often drive the underlying behaviors as opposed to the external problems. And so when that got visible, then there was an easy behavioral change to say that when you are making a change, make this communication visible in this way, communicating in this particular pattern, and it solved the problem. There's much more to it, much more depth, and of course this is connected to metadata visualization and emerging AI tools to be able to swap assets back and forth and much more. But if the trust isn't there, then the dynamic of teamwork is lost, and projects derail and businesses fail. So problem solving happens at all different levels. So this is one example of a complicated problem that we solved with plays.
Yeah. And again, you put that all out there for people to see. They maybe weren't completely on different pages, but it was just some groups of people had more weight on a certain characteristic than others. And putting it all out there kind of helps people come together and make sense of things.
Mm-hmm. And so again, it's interesting that, so two things I would say is having the structure is really critical. So that's the visual structure, because we've created a simple visual structure. In this case, this is an equation, or it can be a bullseye of some sort. Again, provides a kind of context and psychological safety. The question is really critical because you know that you're breaking down the question into subparts that will move you forward. And then the activity that is critical are the actions that people take that create the psychological shift in them to move forward. So the act of going up to a wall with your colleagues, making your equation of trust, and then seeing what their others' equations of trust are, it creates a kind of empathy and understanding in which they're, you find and feel common ground. That's one of the benefits of activity. So problem solving, as we know, is not just a mental activity. It can be emotional as well. And of course, it can also be, we often do workshops where none of this happens. It's all about the technical activity of solving a systems problem, of quantum sensors on spacecraft and or optimizing supply chains and so on. But again, it's the same method, but then expanded.
Right. So as problems get more and more complicated, you kind of run through the same framework several different times and sort of get more and more specific each time.
Yeah, that's right. So a couple of things I would also add to this, and again, I'm sure many of your listeners know of this and have played with this as well. So again, just building on the Pixar model of creative abrasion, agility, and creative alignment, in the course of a problem-solving session, which can be 60 seconds, 2 minutes, an hour, a day, a week, often longer, or sometimes longer, we often need to go through three big phases. So the first is to build a shared understanding of context. So what is actually the problem? What's the data that tells us? What are the forces? How can we best articulate the problem? What is the right model, visual or otherwise, that can accurately and defensively illustrate the problem? And a lot of that is the act of creative abrasion. A second key phase that we also need to move through is to systematically create options, not just one or two options. People often, one of the great challenges of problem solving is that people think they're problem solving, but they're justifying the choices that they've already made psychologically. It's already locked in them. And psychologically, with the 50 some odd biases that we have an anchoring bias. And if we don't surface them by making them visible and not debate them, then we will default to them. And so having the step of systematically creating options that are clearly articulated and different from each other is a powerful tool to actually solve the problem. Otherwise, if you've already made the decision, why go through this process? You're just spending extra, spinning cycles needlessly. And then making bold choices, making choices that matter. And so there are a variety of methods to do that. Again, what's so interesting that for each of these broad phases of problem solving, we can use visual methods to be able to explore and understand these. We've simplified this and made this space. So this whole act that I've just talked about, abrasion, agility, and alignment, context, creating options, making choice, the acronym is we kind of stick it into space where you create the stage, you populate it with context, you create options within the arrange section, you make a choice within the C section, then you exit with a plan.
Okay. So are we ready to move on to a even more complicated problem? or
Sure.
what you call wicked problems. So first, can you tell everybody what a wicked problem is?
Sure. The term was formulated or coined in the early 70s by a couple of researchers from the University of from Berkeley. Actually, they were landscape architects, and they said that there's a class of problems where the solution is very hard or impossible to get to. And they characterize these problems as wicked problems. They're problems that typically engineering or the general problem solving methods available at the time just didn't work. And so they had a list of the 10 qualities of wicked problems. It's kind of zen, because the first one is, I think, defining a wicked problem is itself a wicked problem. Self-referential. But the way I and a lot of other people like to define wicked problems as situations that have qualities of wickedness. And what we don't mean evil, or we don't mean that you're from Boston. It means that there's properties of complexity. So there's a lot of different elements in it. Fluidity, it's changing. It's not something that you can put your finger on very easily. They're often emotionally charged, so people have a strong opinion. Deeply biased, so your way of thinking of the situation is filtered through your experiences. There's dilemmas and trade-offs. In fact, there's another sort of half dozen qualities of these, but these are ambiguous, I would also add to this. So these qualities make it difficult for our brains, our limited brains, to be able to process and make sense of them. So increasingly more and more businesses and more of us face more wicked problems. AI, is complex, it's complicated, it's changing so fast, it's emotionally charged, it's biased, it's good, it's not so good. There are dilemmas. Are we reaching the limit of the scaling law, or are we just in a blimp? I have several large language models a day. Is it improving my cognition, or am I giving the thing that is most human about me, with my ability to imagine and to envision and to articulate and to feel, away to a cognitive prosthetic? So these are wicked problems, as are pick political situations, pick
climate change.
Climate change, for sure. Human rights, develop the issues that developing countries face. And so one of the earlier kind of the original definitions of wicked problems is that you can't actually solve a wicked problem. You can only tame a wicked problem. And for your values and the group that you represent, you can apply methods and tools to be able to steer the outcome towards your particular values.
So we're not going to solve climate change on this podcast.
We only have 10 minutes left. If only it was 10 minutes longer, we would nail it.
But you can give us methods on how to begin thinking about these things within our own lives and with our own professions.
Sure. So there's a great body of knowledge. We run courses on this, and there's fantastic tools, design thinking tools, and others that will guide you and others to tackle your wicked problems. But what I would suggest is there are things that, as systems engineers, that we can do to extend, deepen, and widen the capabilities that you use every day to address a wider set of problems. And they are what we've already talked about. So the first is to make it a habit to, when it's important, externalize your thinking. And that is expand your visual toolkit. Know how to use a line, a 2x2, a circle. Know the dynamics of a systems model. Again, this is a short podcast, so we didn't go through the 20 essential diagrams that help you arrange information, but that information can really help give you more models and tools that you can bring to bear to the situation at hand. Number two is to facilitate, don't just solve problems. That is to, in the act of running a play, also being a coach to help others on your team and your customers select plays that are better and run them well. So some of that is quite physical. If you're doing sticky note, making sure that people write complete thoughts on their sticky notes and that they exhaust the potential of ideas, the ideas that they need to present. And then also coach them on the effectiveness and the efficacy of the play. Did you really expand? Did you, or are there other ways of looking at this, et cetera? Facilitate, don't just solve. Think in terms of plays. And the purpose of that, again, is to pause and select the kind of thinking that fits the problem that you're facing. And so as a systems engineer, you've got an incredible set of resources to bring to bear, and they feel complete. But what would a lawyer say to the problem? What would a physician say? What would an evolutionary biologist? They have different questions which they visualize in different ways, which are also plays. So by incorporating the questions that others ask, the values that they embody, and the actions that they perform, you dramatically expand the range of ways in which you can think, and I think dramatically improve your value within your organization and with your customers.
Quick question on that one. Is there ever too much expansion? Do you ever get too many thoughts and inputs? Does that cloud things up?
You bet. So, a good coach will know when to stop the creative abrasion phase. We've got enough ideas. We have enough conflicting ideas. We now need to go into the development of them, testing them, creating prototypes of them, making sure that they're aligned with the values or the needs of the organization and the problem that we're trying to solve. So I think there's a little bit of art and science with that. And different industries face different challenges. In some industries, there's just a rush to the first solution. The impulse to leap to a solution is generally a bigger problem to solve than spinning around having too many solutions. The fourth element was lead with questions. So the act of pausing and in advance of every play, get clear about what are you trying to solve? What smaller question can we untangle so that we can move to solve the bigger question? Think of trust. The big question is hard to take in one gulp necessarily, but by breaking it down in this analytic approach, we can make smaller jumps, smaller leaps that certainly in a group are easier. Become masters of questions, use them strategically. And then finally, just continue to cultivate a curious mindset. I think the curiosity of how the world works, how we can solve problems, how good you are as a problem solver, how you can become better, what are your blind spots. That visual and systems mindset is the flywheel that keeps our skills growing. I'm kind of mixing metaphors there, but that's these are the 5 things I would suggest are great next steps to continue to get better in any profession.
So these steps may come very naturally to some people. They might find these, they have strength in getting through these. Other people, maybe not so much. So if you find that you're short in an area, how do you recommend somebody kind of betters their skills at this?
Again, we have a whole series of training courses. We've licensed them to many large organizations. They were used by PMI, the Project Management Institute. Well, I say on a practical level, have a notebook that has no lines in it or a grid dot. So externalize your thinking and ask yourself, how do I turn this into a picture? There's a great book called Art Before Breakfast, which is a little drawing book that is just a fun little thing, a little 5-minute exercise to get your brain warmed up. And it's I've enjoyed that as well. Facilitate, don't just solve, I think is really taking a leadership position. So rather than being the person who's on the stage that is solving the problem, which you sometimes need to do, sometimes a better solution is to ask questions of the group to coax them to a better solution.
With these visual models, they've shown to be so effective. Why do you think that they're not used more?
That's a good question. I think there is I think there's a couple of reasons. One is we think that drawing is a child or childish activity. And so even though we have fun drawing, there is an association, often with very senior leaders, that I don't draw because it is beneath my elevated skill level. And a flip side to that is that we often value eloquence and articulation over simplicity and clarity. Second is that it's just not taught because it's not part of our culture. I'm kind of on a mission to teach and educate people to draw more. And I'm not a particularly good illustrator or drawer, but I make hundreds of sketches a month to help our customers think about things. And it's not about the technical skill that's important. It's the knowing the language, and that can be taught in a day.
Well, Tom, you've shared your knowledge and expertise with corporations all over the world, and now you've shared some with us today. And our listeners can learn more about everything that we've talked about in our show notes. Is there anything else that we wanted to say about anything else that we've left out?
We are relaunching. We're launching a whole set of courses on January. So these and other methods. So we are launching courses on how to use visual thinking to address simple, medium, and complex problems. And there's apps and decks of cards and so on. We have another course on making meetings that don't suck, which use these methods and tools. And soon we'll have courses on managing projects. You can go to tomwujec.com, and that'll be the master location for where to get courses and books and other material that you might be interested in looking at to learn more about these methods and tools.
tomwujec.com. All right. Well, Tom, thank you so much for being with us today on Problem Solved. I appreciate it so much.
It's totally my pleasure. Thanks for the invitation.
Thanks for listening to Problem Solved, the IISE podcast. Don't miss our next episode on October 7th, where we share how ISE methods solve everything from global food security to Taekwondo performance. Check out the show notes for resources from today's conversation with Tom Wujec, and a special thanks to Tom and IISE's Performance Excellence webinars.